Hello, in this video we're going to take a look at a couple of application problems involving quadratic functions. The first one we have a suspension bridge with weight uniformly distributed along its length has twin towers that extend 65 meters above the road and are 400 meters apart. Find the height of the cables at a point 100 meters from the center. So this one really has two parts. One where we have to find an equation that models this parabolic shape and then use that function to find the height of the cables. So this one we've got a question as far as what we want to define our variables to be. You could define your x and y axis to be probably pretty straightforward and easy to see that if we want, we could make our x-axis be along the surface of the road. And then we've got two places where we could have our y-axis. We could have our y-axis on one of the towers, or we could have our y-axis going down the middle of those towers. Since we are looking at the second part here, we want to know from the center, it's going to be a little bit easier if we define our y-axis to be along that center of right in between our two towers. Okay, this problem, first thing we've got to do is find an equation. We know the coordinates of our vertex because we've defined them to be at the origin, so we do know that our vertex here goes through the point 0, 0, and our parabola goes through, well, we know for sure the 2 points over here. If our towers are 400 meters apart, that means that the x coordinate is going to be 200 to the right or 200 to the left, and so we get that our x coordinate is going to either be plus 200 or minus 200, and we really just need 1 point. And then we know that our towers are 65 meters above the road, so that's giving us our y-coordinate at those 2 points. And so we can use either one of those. We know that it goes through the point either plus or minus 265. And we're going to use that to find the equation of our parabola. So we're going to use since we know the vertex, it's going to be a whole lot easier to use either that HK or that standard form. We know that a parabola can be written in the form of y equals a times x minus h, quantity squared, plus k. Don't forget about that square there. Here, h and k are going to come from our vertex. That's the x and y coordinates of our vertex. And our point, I'm going to go ahead and use the positive 200 here, is giving us our x and our y value. So we're going to plug in 65 for y. We don't know what a is. That's what we've got to find out. Our x value can be either plus or minus 200, and our h and k value are both 0. So simplifying this, we're going to get 65 equals a times, we're going to have 200 minus 0 is 200. When we square 200, we're going to get 40,000 times a. And so we get 65 over 40,000. And we can simplify that. That simplifies to 13 over 8,000 is our a value. So the height of our towers can be modeled by the equation y equals 13 over 8,000 times x minus, our vertex is still at 0, 0, so x minus 0 squared plus 0, which is the same thing as 13 over 8,000 times x squared. So x coordinate here is giving us our distance from the center, and the y coordinate is giving us the height of those cables. So if we want to find the height of the cables 100 meters from the center, we're going to plug in 100 for x. So we get 13 over 8,000 times 100 squared gives us a height of 65 over 4, or 16 and a quarter units on this are meters. So it's a little bit more than 16 meters off the ground at the point 100 meters from the center. All right, our next example, we have a rain gutter to be made of aluminum sheets that are 16 inches wide, and we're going to turn up the edges by 90 degrees. So we're going to take our aluminum sheet that we don't know how long it is, but we do know it's 16 inches wide. We're going to take that and we're going to fold up those edges so that what we get gives us the shape of a rain gutter. So let me actually turn this on its side just a little bit. So we're going to be looking at it and we're going to have those edges we're going to fold up so that what we get is a rain gutter shape. And we know that the total we start with is 16 inches. So if we let here, we're wanting to know what depth, and so we'll call that depth our variable x. So we'll let x be that depth, and it's going to be the same on both sides. So if we take 16 inches and we fold up x inches on the left and x inches on the right, what we're going to be left with across the bottom is going to be 16 minus 2x. All right, so we want to know what depth will provide the maximum cross-sectional area and allow the most water to flow. Well, we don't really know our area function just yet, so we've got to find that. If we want to maximize that area, we need to find our area function. Remember, area is going to be length times width, or in this case, height times width. So x times 16 minus 2x. So x times negative 2x is going to give us negative 2x squared, and x times 16 is going to be 16x. That is our area. That is a parabola that, since that leading coefficient is negative, it will have a maximum. And that maximum is going to occur at the vertex, and that's going to be when x equals negative b over 2a. So negative 16 over 2 times negative 2. That's going to, negative and a negative are going to divide out and give us a positive. 16 divided by 4 is 4. And so our answer here is 4 inches is going to be the depth that will maximize that area and allow the most water to flow through it. Now part B, what depths will allow 30 square inches to flow? Well, if we want our area to be, if we want that area to be 30 square inches, we're going to plug in 30 for A, and we can use either one. I'm going to go ahead and use the expanded one. Negative 2x squared plus 16x, and now we just need to solve for x. So it's a quadratic equation. We can use any of the methods that we learned solving quadratic equations. If it'll factor, we can factor it. If not, we can always use the quadratic formula or complete the square. We want to go ahead and move that 30 to the other side. Negative 2x squared plus 16x minus 30. And I do see that all of those are even numbers, so I'm going to go ahead and make these numbers smaller by dividing everything by a negative 2. That's going to give me x squared. 16 divided by negative 2 is negative 8. And negative 30 divided by a negative 2 is going to be a positive 15. And this one will factor nicely. Factors of 15 that add to negative 8 are going to be a negative 5 and a negative 3. So when we set each of those equal to 0, we get x equals 5 and x equals 3 inches. So those are the two depths, that will give us a 30 square inch cross-sectional area. All right, I'll see you guys next time.